Okay, so for this question, it's a question of tension, and it will emphasize the nuance about tension um, being positive, right? So we're given that a mass M is held by a inextensible string, and the string has a breaking strength of T equals to 4 mg. So that means the moment T is equals to 4 mg is going to break. So in other words, we are limited. T must be less than equals to 4 mg, the tension in the string, right? So we want to find the maximum positive and negative accelerations, given that they define the direction to be upward positive. So yeah, so if you consider the force body diagram on this mass M, then we can see that there's two forces. One is the tension, right, and one is gravitational mg. So the formula, right, is just the net force is just T minus mg, and the acceleration is ma. I mean the net force is equals to ma, so the T minus mg is ma. So if we rearrange this, you can see that T is equals to mg plus a. Right, so this a, we're asking the question, what is the maximum positive and negative value for this a, right? T is bound by two things. T must be always greater than or equals to 0, right? By the very nature of the string, right? Because T equals to 0 means that the string is no longer pulling the object up, right? If T is negative, right, then that means we're flipping the direction of the vector. That means the string, and that means the string is pushing the object down, and that doesn't make sense because if you ever tried to push, right, an object with a string, you realize that the string will just buckle, right? So the nature of the string means that tension must always be positive. Okay, so there's no way for the tension to push the object down, right? It can only pull the object up. And okay, so there's one bound for tension, and the other bound for tension is given in the question. We are told that the breaking strength of the string is 4 mg. That means that the moment this T, if the magnitude gets too big, right? If it gets to 4 mg, then it's gonna break, right? So the other bound is this. Okay, so with this, right, we can see that if we substitute our expression for T inside, then we get that 0 less than equals to g plus a less equals to 4g, and minus g on both sides. A is bounded between minus g and 3g, right? So the answer for the maximum positive and the negative acceleration will hence be 3g and g respectively. Hence the answer is D. Okay, so this question emphasizes the fact that your tension, right, cannot be used to push an object down, right? The case of T equals to 0 just corresponds to having essentially no string at all, right? The string is not attached to it, right? It is letting the object fall in free fall, and in that case, it's gonna fall at acceleration g, okay, in a negative direction. So yeah, so that's how you do this question.